Hello everyone, welcome to another exciting episode of Physics with Noshir Alam, and we'll be doing some more practice questions on errors and uncertainties, and then I will continue with the topic of vectors because a lot of students are facing trouble in that. So let's bring up a question in front of you first so you can have a look at this question over here. The question says, you've seen this question before with me, but you did not solve the question in its full length. Today you're in that position to solve it in its full length. The first part is that you have to find out the base units of K. We have done this part in the previous video and we've done this part as well in the previous video. So I'm not going to solve these two parts, but I just want you to understand that this equation over here is very important, which is T is equals to K ml cube over E under root. And today's lecture is going to basically solve the error part of the same question. So I will remove this part from here and we drop this off. And let's bring this part here. Okay. So starting off with this question, your equation was T is equals to K square root of ml cube over E, and they're asking you to find the uncertainty in E and the value of E. So the first thing is, remember, in any such question, whenever they ask you that you have to find the value of E, but you can clearly see that E is not the subject, always make that quantity the subject of the equation. जिसके अंदर भी आपने value और उसका error निकालना है. So the first thing is you make E the subject, and when you make E the subject, you end up getting the equation T square is equals to K square ml cube over E. Remember, you get rid of the square root, and then when you make E the subject, you get E is equals to K square ml cube over T square. This is the equation that you get. Now all that you have to do is, if you zoom in on the values of K, L, M and T, you plug them in and you find out what the value of E is. And the value of E, when you plug in all the values correctly, E will be equal to K square, which is 1.48 into 10 to the power 5 whole square, times mass, which is 0.2068. Then you put L cube, which is 0.892 whole cube, divided by T square, which is 0.45 whole square. When you plug in these values, you end up getting the value of E as 1.588 into 10 raised to the power 10. I've done it in the calculator. You can also check it later. 1.588 in 10 to the power 10 is the value of E. So that's one part solved. But the actual part, the real part, is about to say the asal part. The real part is on how would you get the uncertainty in E. So for that, I'll move this up and let's focus on our equation again. Now, the uncertainty part, again, realize from the previous lecture that this is a question on multiplication and division. So you have to take percentage errors and not absolute errors. पहले percentage निकलेगा फिर absolute निकलेगा. So what will you do? You will calculate percentage E first. Percentage E is equals to K square will be 2 percentage K plus percentage M. You must remember the rules from the previous lecture. If you are finding this difficult, why did we write this as 2% K? Why did we write it as percentage K square? Then that means that you need to visit the previous lecture again. So 2 percentage K plus percentage M plus 3 percentage L plus 2 percentage T. This is your error equation. Now the good part is that they have already given you the percentage errors of each value. So if you look closely, the percentage error in T is 2%, percentage error in K is 1.5%. So let's start. So percentage error in K is 1.5%, so I can write 2 times 1.5 plus percentage M is 0.1 plus 3 percentage L would mean 3 times 0.2, and plus 2 percentage T would mean plus 2 times 2. You add all of them, this is 4 plus 0.6 plus 0.1. That's 4 plus 0.6, 4.6, 4.7, 4.7 plus 3%. So in total, what you end up getting is 7.7%. That is the percentage error in what? This is the percentage error in the value of E, which you had calculated earlier, which was 1.58, and put it here. The value of E was 1.588 into 10 raised to the power 10. So what do? You take 7.7% of this value. So you take 7.7% error किस चीज में? E की value में. So 7.7%, because you want to calculate delta E, you should do 7.7% of 1.588 into 10 raised to the power 10, and the value that you end up getting is 1.22 into 10 raised to the power 9. Now, how do you write the final answer? If you remember from my previous lecture, I told you that errors always have to be written correct to one significant figure, but this is nowhere close to 1. So let me move all of this up and let's focus on the value. So okay, here we go. So delta E is 1.22 into 10 raised to the power 9. I want to calculate the value of delta E to 1 SF. So it should be 1 into 10 raised to the power 9, because 1.22 is 3 SF. Now, another thing, let me bring back the value of E. Please focus on this value of E. The value of E is 1.588 into 10 raised to the power 10. I'll write it down over here. The value of E was 1.588 into 10 raised to the power 10. Always remember that you have to match the power of the actual value. So 10 raised to the power 9 needs to be converted to 10 raised to the power 10. So I can write this as 1 into 10 into 10 to the power 9 divided by 10. Because you know that the two 10s would cancel each other out as well if need be, and there would be no effect on the answer. But the good part, the advantage of doing this is that if you write it like this, then you end up getting 0.1 into 10 raised to the power 10. So your error is 1 SF and the powers have also matched. Now the last step is, I told you this, that look at the decimal places in the error. You should have the same number of decimal places in the value. So your value of E is not 1.588, it's going to be 1.6 into 10 raised to the power 10. So your final answer would be 1.6 plus minus 0.1, put brackets around it, into 10 raised to the power 10. I hope you all understood the question. Alright, so let us now begin with the topic of vectors. In vectors, we start from O levels, that a vector is any quantity which has magnitude and direction. So the length of this arrow represents the magnitude and the arrowhead represents direction. So length represents magnitude and the arrowhead represents direction. Now, basic O-level question. You have an object, alright, and I say that there is a 2 Newton force acting this way and there is a 3 Newton force acting this way. And I ask you to tell me what is the resultant force. You will say the resultant force is 1 Newton this way. Then, if you have the same object, you have a 2 Newton force this way and you have another 4 Newton force this way, and I ask you for the resultant force, you will say the resultant force is 6 Newton this way. So when two vectors are acting in the same direction, you add them, and when two vectors are acting in opposite directions, you subtract them. Let's pick up another question. So I say that you have a 3 Newton force, a 4 Newton force, and a 5 Newton force. and I say that I want you to find the minimum possible resultant force and the maximum possible resultant force from these. Alright, so if you're trying to find out the minimum possible resultant force, that's going to be tricky. The maximum possible resultant force is not difficult at all, because you can say that this is, let's say, your object, and for the maximum force, all you have to do is that all three forces are acting in the same direction. So this is 3 newtons, this is 4 newtons, and this is 5 newtons. So the resultant that you will get is 3 plus 4 plus 5, which is 12 newtons this way. This is your maximum possible force. But if you consider the minimum possible force like this, that you put 4 and 3 in this direction, 4 and 3 in this direction, and put 5 in this direction, and then you find out the resultant to be 2 newtons, then I can give you an answer. I can tell you of a force which is less than 2 newtons. Have a look. So the same question, that you have a 3 newton force, a 4 newton force, and a 5 newton force, and the question is you have to find out the minimum possible force and the maximum possible force. What if you put the 3 newton force this way, and what if you put the 4 newton force this way? Because nowhere in the question have they said, कहीं पे नहीं लिखा हुआ question में कि तीनों forces का direction क्या है. All they are saying that you have these 3 forces, they can act in any direction. That means, so मैंने यहाँ पे 4 लिखा हुआ है, you can put 3 over here and you can put 4 over here, and the forces are acting at right angles to each other. So if I ask you what is the resultant, you will say the resultant is this. This resultant can be found out by using Pythagoras theorem, which is hypotenuse squared is equals to base squared plus perpendicular square, which you've already done in O levels. Please bear in mind that right now I have only used these 2 forces. I haven't used the 5 newton force. ये खाली पड़ी हुई है, इसको मैंने नहीं उठाया अभी. I'm just picking up these 2 and I'm finding their resultant over here using this rule over here. Hypotenuse square is equal to base square plus perpendicular square. So hypotenuse square, you have to find base is 3 and the perpendicular is 4, so the hypotenuse would be 5 newtons. And if you're having difficulty picturing it, basically you bring the 4 newton over here and extend this, and this is what your triangle looks like. So this hypotenuse over here is 5 newtons. This is 5 newtons. Now we pick up this 5 newton force and we put it exactly opposite the resultant of those 2 forces. This is 5. So what is 5 minus 5? 0. So your resultant force is 0 newtons, and this is the minimum possible force. Now, I hope you've understood that. Let's take it a notch above and let's come into A levels. So in A levels, we'll start off directly with a question, and first I'll teach you the concept of vector resolution. Now, what is vector resolution? Vector resolution basically means that you will have a vector, any vector, let's say the vector is called t, and t is acting at an angle theta degrees to the base. The first thing that you will do is you are going to make the components of t. Please try to make some sense before you make components. गौर से देखो, when you look at this t, it's going, I'll ask you the question, you can answer the question. Is it going left and up? Is it going left and down? Is it going straight up? Is it going straight down? Is it going right, or is it going right and up? Your answer should be that this t is going right and it's going up. So that's what vector resolution is. Now, you will make an arrow from the start and you will make sure that the arrow goes right, but question is, how long should this arrow be? Should it stop here? Should it stop here? Where should it stop? The answer to that is that you should know where to stop the arrow only by making a vertical line from here. So you make a vertical dotted line down, straight down, and that will tell you where to stop. So let me make that vertical line for you. Here is that vertical dotted line. When you have enough practice तो आपको ये line draw करने की जरूरत नहीं पड़ेगी, but for now you have to. So you make this vertical dotted line and you bring this here. This is your horizontal, and this is your vertical component. All right, remember that the two components must always be at 90 degrees to each other. So now you apply some maths. So you all understand sine theta is perpendicular over hypotenuse, and you understand that cos theta is base over hypotenuse. So perpendicular can be written as hypotenuse into sine of theta, and base can be written as hypotenuse into cos of theta. Now when you look at this question, your hypotenuse is t, so I can basically write this as P is equals to T sine theta, and the base will then become T cos theta. So the horizontal component is called T cos theta, and the vertical component is called T sine of theta. What you need to always memorize is, please do not make this mistake that if you think that the vertical component is always this one, that's wrong. हम वर्टिकल किसको कहते हैं? हम कहते हैं एंगल के सामने जो होता है, सो जो एंगल के सामने है वो वर्टिकल कंपोनेंट है, और एंगल के सामने वाला कंपोनेंट हमेशा साइन थीटा वाला कंपोनेंट होगा. You may be wondering what difference will it make? Well, why don't you try this? Let's say that this is my vertical, all right? This is the reference. And I take a vector P, which is acting at an angle theta. I want you to pause the video and make its components, and I'm giving you this angle over here, and then write down which is sine theta, which is P sine theta, and which is P cos theta. All right, so I hope that you have drawn the right components. You made the sense first that this arrow is going down and right, so the components should be pointing down and right. Somebody wants to make it like this. You want to go right first and down then, that's also fine. But look at my angle. Go with the angle always. If you go this way, you will have to consider this angle. So why do you want to do that when they've already given you the angle? So just go down and right. So going down and right means going straight down like this, you stop, and then you move this way, and you exactly know that this angle is 90. Now, this component is P sine theta, and this component is P cos theta. What did I tell you? And if you don't believe me, do the math yourself. I told you that the vertical in math is always the one which is opposite the angle. So P sine theta, which is the vertical component, will always be opposite the angle. Once you've decided which is P sine theta, then this will automatically become P cos of theta. Another thing, because you're doing vector resolution with me, so now we can start off with a proper structured question. Let's say I have this slope, all right, and the slope is inclined at an angle theta, and this is an object. You must have noticed whenever you're going downhill, the object naturally goes this way. So if you put something on an inclined plane, the object naturally slides down. It naturally, you don't have to add any force, and it'll naturally go down. And you need to understand today why. So the force that is acting on this object is the weight. Weight always acts perpendicularly downwards. Remember this? Weight does not act downwards, it acts perpendicularly downwards. Why? Because you could say that this is downward, but this is not the direction of the weight. This is downward, this is not the direction of the weight. Weight always acts perpendicularly downwards. Now, remember that this object
is neither sinking into the ground, ground के अंदर भी नहीं आ रहा, ये ground है, ये plane है आपका, ये slope है, ज़मीन तोड़ के अंदर भी नहीं आ रहा है, and it's not going out as well, it's not flying off. Just like imagine that you are coming down from a hill, तो ना आप आसमान में उड़ के जाते हो, ना आप ज़मीन तोड़ के ज़मीन के अंदर आते हो. That means that there must be a force which is balancing normal reaction. हर surface के ऊपर, whenever you're standing on a surface, let's say this is the surface, this is you always experience a normal reaction. Now, when you're standing on a normal surface, normal reaction is equal to weight. It's not inclined. So, what is balancing this normal reaction now? There must be a force in the opposite direction. So, let's make that force in the opposite direction, and I'll do it in a different pen. So, this is that force. All right. अभी तक कितना ही समझे? Now, let's start off. This angle is theta. So what is this angle? This angle is 90 degrees. This angle over here, this is 90 degrees. So let's make it 90. I have to ask you this question. What is this angle then? You will say 90 plus theta plus x is equals to 180. So this will be, I don't know, theta minus 90 or 90 minus theta. Doesn't matter. Then I will ask you to find out what is this angle. And to find out this angle, I would suggest that you zoom in and have a close look at what this angle is. What is this angle over here? This is also 90. Why? This is 90. This is 90. So this should also be 90. So this whole angle is 90. Please follow the cursor. This angle is 90. So what is 90 minus theta minus 90? It'll be minus theta. Ignore the negative sign. We don't care about the negative sign. The angle is theta. Angle is theta. The magnitude is what matters right now, not the sign. So the angle is theta. Now, what you must understand is, let me zoom out. What you must understand is that it's the weight, and this is one component of weight. So the other component of weight will be this way. This is the weight, this is your resultant. This is one component of weight, and this will be the other component of weight. And if I ask you कि मुझे ये बताएं कि इस component और इस component के बीच में angle कितना है? So what is the angle between the two components? You will say the angle between the two components is 90 degrees. So what you will do is you will make the other component of weight, and that component of weight will be this way, and this angle over here is 90 degrees. So I have to ask you this question. If this arrow, the red arrow that's vertically down, this arrow, this is weight, this is theta, क्या डिसाइड किया था? एंगल के सामने वाला कंपोनेंट कौन सा होता है? योर आंसर शुड बी दिस इज W sin theta. And then the question should be, what is this component over here? And your answer should be, this is W cos of theta. So those are your two components. Now, your question should be, why does the object naturally go down? अगर आप handbrake गाड़ी की उतार दो, you don't pull the handbrake on a slope, the car naturally goes down. Look at the force which is in the direction. Is W cos theta in this direction or W sin theta? You will be very quick to realize, inshallah, that it is W sin theta is the component along the slope. And this is responsible for bringing you down. And what about W cos theta? W cos theta is balancing out the normal reaction. That is the reason why the car does not fly off into the sky and the car does not sink into the ground either, because these two forces are equal. But if I ask you in very simple terms that you are accelerating downwards, and why are you accelerating downwards? You will say it's W sine theta, which is bringing me down. So W sine theta is responsible for the object accelerating downwards. Now, I'm going to assume that there is no frictional force right now. Assuming no frictional force, if I assume no frictional force, then W sine theta is the only force which is pulling the object down. So W sine theta, this force is the only force which is pulling the object down. So I could say W sine theta is equals to forward force. जहाँ आपने A लिखा हुआ है, वहाँ पे आप F भी लिख सकते हो. F means force, and wherever there's a force, there's an acceleration. So what is the force which is pulling you down? W sine theta is pulling you down. Because you haven't applied any force yourself, the weight is naturally letting you come down. Just imagine, why is it always easier to run down a slope? Because your weight is helping you run down that slope. So the weight, component of weight, W sine theta, is providing you the force which gives you that acceleration. So W sine theta should be equal to the force, and then you can say mg sine of theta is equals to ma. M and M will get cancelled. So the acceleration, if they ever ask you for the expression, that is equals to g sine of theta. And for Earth, you all know that the value of g is 9.81 meters per second square.
So that is all with today's episode of Physics with Naushad Alam. We will continue vectors in the next episode. I hope you've got a good understanding. I apologize for the voice because I'm not in my studio, I'm outside. So that's why the voice may be a little scratchy. But inshallah, next time I'll be making it in my studio. Alright, guys. Have a great day. Keep sharing, keep liking, and do comment so I know what your understanding levels are. Brilliant. Take care, guys. Have a great day.